Hey, so welcome to this ViZDoom series where we're using policy gradients reinforced to learn to create a machine learning model that will control the ViZDoom game and hopefully learn to play. A quick recap of what we're doing. So there's a bunch of videos that go before this. I'm never really sure about how much to recap what's gone before it. So let me know in the comments if you got any opinions on this. Like, should I skip the recap or should I do the recap? I don't know. I mean, I put chapter headings in anyway, so you can always skip the recap if you hate it. But maybe you can give me information about whether you use the recap or not. So ViZDoom is like a first-person shooter game from the 90s that runs just using a CPU. It doesn't even need a GPU. It's kind of old. It's kind of like it predates Quake, which predates. Well, I guess it predates Quake, right? Because Quake had multiple versions. So ViZDoom basically wraps the Doom with an API so that you can call it easily from a machine learning environment such as PyTorch or from Python or whatever language you want really. I mean, well, I don't know what APIs they have, but they certainly have an API for Python, and then it's easily possible to create a machine learning model which you then use to drive the ViZDoom. And so what we're doing is we're trying to use policy gradients reinforced to get the model to learn one of the scenarios. Now, I've never tried using reinforcement learning on this scenario before or on ViZDoom, so it's a learning experience for both of us, so I don't know what will happen. Now, up till now, basically, I've just been kind of recording like a little chunk of what I'm doing to get that far each time. But then yesterday, I came across a little kind of metaphysical problem because I started training things that take a long time, and I I don't have the patience to wait for the training to complete before I want to start working on the next video, right? So, and also in reality, even if I wasn't making a video, I would be trying new things. So the metaphysical conundrum is, should I record videos of multiple things in parallel, but present them as though they're in sequence? Or should I record them and present them in chronological order as I'm actually doing them? And it's I don't actually know. So let me know your opinions in the comments. I think for now I'm going to try it in chronological order. So I'm going to try to present what I'm doing with my reactions as they happen. I also need to start getting into the habit of recording when I'm checking things, even if they're very small things where simply checking how it's looking after running overnight. I think I need to start take the effort to set up the microphone. Here it's on the boom, but if I'm in an internet in a coffee shop, then I need to get out the tripod, set out the microphone and stuff, do all of that, which takes 5 minutes, just to check the log, so that then my reactions will actually be genuine and so on, right? Which I think is more interesting for everyone. But I need to start doing that, which means I haven't really been doing that. But I'm going to start doing that. All right, so here's my plan. I'm going to present things in a chronological order, like what I'm actually doing in order for now, and let me know your opinions if you've got a different idea. So basically, I'm going to be running multiple experiments in parallel, basically. I mean, for this video, there's only 2 experiments that are happening in parallel, but there could be more potentially. All right, so I woke up this morning after leaving my instance to run all night, and this is the graph that I saw. So this is a graph of reward against episode, and as you can see, the learning club. So it went up to 250,000 episodes, and to start with, it learned, and then I was asleep, and then I woke up 4 or 5 o'clock in the morning, and learning had collapsed. So I've started it running again, but so far it's looking like this, and so we just have to wait. But meanwhile, I kind of would like to do something about this graph. You can't get rid of this in all occasions, especially using policy gradients. It does tend to be unstable and collapse occasionally. It doesn't remember stuff. There's no replay buffer. I'm not sure if anyone ever uses a replay buffer with policy gradients. I mean, I guess you might be able to use some teacher forcing. I don't know if anyone's ever done that. I'm not sure. Replay buffer normally gets used with things more like Q-learning, Anyway, we don't have a replay buffer and we're using policy gradients. So basically, the network learns to do things a certain way. And then if it ever does something very slightly different, then in the next time steps, it sort of falls off the path that it's expecting. And then sometimes it just sort of collapses. I kind of think that we might be able to stabilize this if we accumulated gradients over multiple episodes and then backpropped. Because like some of the episodes, it wins and shoots the monster and it gets like a nice positive reward. And some of them it fails and gets a huge negative reward. And so that means the gradients are going to be all over the place. And so I feel that if we average over, like say 16 episodes each time by just simply accumulating gradients, we'll stabilize the learning. So I want to try that. So let's look into doing that. All right, so let's copy ViZDoom part 6 to ViZDoom part 7. All right, so we moved the model into a separate file called model.py, which hopefully is in GitHub, but I can't remember, to be honest. I'll check afterwards. And then we've got if name equal main, and then inside this we've got a loop over the episodes. This while true, the I is the episode. We should probably rename that at some point. And then here we've got a loop over the steps within each episode. And then just after all of the steps of the episode, at the end of the episode, we are using reinforce algorithm to calculate the loss, and then we are backpropagating the loss after zeroing the gradients, and then we're taking a gradient step. So what we will change is basically we will only zero the gradient and take a step. Well, we will reverse the order of this firstly. So we will take a step and then zero the gradients. And we will do this like every 16 episodes. And then we will leave that running while I'll start as another instance. We'll leave that running while the other one's running, and then we can like have a look at the two. The other thing I would like to try is entropy regularization, but like let's not try everything at once. So here we're going to try the accumulating gradients. All right, so basically here we'll do very simply, if I percent 60, let's say accumulate steps. If this is 0, then we're going to take a step and zero the gradient. That's it. And, you know, because we're averaging out this stuff in the log file anyway, why don't we only write to the log file like every accumulate steps to, rather than, and so that will make it cleaner, like it will smooth out the trace in the log file. So let's do that. So first let's define accumulate steps. So we'll set that to 16. And we should probably migrate this to argparse at some point. But anyway, I mean, I'm just keeping it as simple as possible. I mean, in reality, I might use like MLflow, for example, to log these, but I don't want to make it too specific to particular infrastructures, and we'd have to like set up the MLflow. So here I'm just logging to a text file, which is what I did for years, to be honest. And it just makes it simpler. Like we don't have to learn about MLflow and stuff. But like in reality, you might be using MLflow. A slight digression there. Anyway, right. So here, so let's accumulate the losses too. So well, we've got a few things to accumulate, right? Well, okay, total loss equal, I'm not sure if we should start it off as a torch.tensor, if that will work. Or if we can start it off with 0.0. I don't know if that will work, actually. We'll just try that and see if it works. If it doesn't work, we'll change it. All right, so like it might not work because it might not have a gradient. All right, so here we're going to do total loss plus equal loss plus equal total loss plus loss. And here, let's put this here. And then I would call it like, I don't know, batch reward. So we'll call this like accumulate steps. We'll call this a batch. And yeah, so let's call this batch loss and batch reward. I don't know if this has to be a torch.tensor. I guess we'll find out. So total, so this we'll call batch loss, and we'll set that to 0 here. And we've also got batch reward equal batch reward plus, and then we'll get the reward from here, right? Okay, so batch, I guess this will be divided by accumulate steps. Reward, here we'll do batch reward. And let's do like %3f or %1f. And here we'll do loss. And this will be batch loss.item. All right, so we'll do the loss.backward each step. So the gradients will be calculated each step. We simply won't make the optimizer step. We'll accumulate gradients. So basically the gradients, when they backpropagate, they'll simply be added into the gradients for each of the parameters. And then after like 16 steps, so 16 episodes, we'll then do the backprop. I mean, not the backprop. We'll do the optimizer step where we update the weights. And then here we set all the gradients to 0. All right, let's just put this here. And I guess we can just do this because, you know what? So the batch loss, it doesn't need to have a gradient because we're backpopping immediately. So we'll just make this into a scalar by doing the dot item. And I guess the total reward is probably a scalar because you can't backprop reward. So that should be good. So here we'll call this batch, and loss will be batch loss. Q divided by. Well, let's call this B. Oh yeah, and batch reward also equals 0.0. All right, so this is the batch number. Like we're basically sort of creating like this virtual batch concept by only updating the optimizer, only updating the weights every accumulate steps. Maybe we should call this like accumulate episodes so that we don't mess around with the notation. So up here, we'll call this, and I guess we can add a comment. How many episodes between optimization steps? All right, let's try running that and see what happens. So yeah, I have to do Python path, right? I mean, I could be not lazy and actually create an installable module, but so first it's going to, oh, okay, right, yeah, because I made it not over here, right? Because I made the batch loss just a scalar. All right, so this is like 16 episodes worth. Actually, should we check that somehow? Well, we know that it is because the batch number is I divided by accumulate episodes. So basically, the next time there's a batch, it should be, like, if it's 1, then that means that I is at least 16. Otherwise, I divided by accumulate episodes would be 0. All right, so there we go, batch 1. All right, and The reward seems like not as negative as I would expect. Like if it's getting an average reward of say like minus 200 and there's 16 steps, we would expect that to be like minus 3000 or something, right? So that makes me suspicious. Batch reward equal batch reward plus game.total reward. And then batch reward plus batch reward 0. This is over episodes. We only set this to 0. Oh, right, yeah. All right, let's try that again. All right, that's better. That's... Wait, is it better? I'm not sure. Should we be reporting average reward and average loss, maybe? Kind of feel that would be more intuitive, right? Let's report average reward and average loss. So we're going to divide this by accumulate. All right. All right, so this reward is more like what I would expect to see. And probably... because the very first time through, it only does a single episode, that's why. So we should do like maybe if I plus 1, and that way it won't do something on the first episode. Yeah, that should be fine. B will still be correct. Yeah, that should be okay, I think. All right, so let's try that. So like these were what we would expect when we're not averaging. This is what we would expect if we are averaging. But the thing is, this is because it's only over a single episode. This is over 16 episodes. What we should see now is, because doing an average, we should get something more like this, but it should hopefully be over like 16 episodes. And it seems that it is because it's taking a long time. I guess we could just use like 4 to test, I guess, but I'll probably just like fast forward through time or something if there's like long gaps. So what I'll do once this seems to be running okay is then I'll go and start a new instance and then run it on the new instance. And I'll leave the old instance running. All right, so that's it for this video. And then in the next video, we will look at... all right, so these are the models that have run or are currently running. So this is the first run we did where it learned, but we hadn't saved the model. This is the second run we did, which I talked about in this video, where it did learn. That's what I've marked in green, and then like before I woke up, it collapsed. This run I started in the morning. When I woke up, I noticed this was broken, so I started a new run. And then at the end of this video, we started this new run, which is using gradient accumulation. So it's kind of like virtual batching. We probably need to let this one run for a while to see if it's stable or not. This run hopefully should finish really soon. So likely the next video is going to be able to show a demo of like how the model actually plays when it's playing the game. Any comments, ideas about presentation, chronology, whatever, please put in the comments. Or if you like the video, please press the like. And hopefully I'll see you in the next video.